Data Acquisition Series Part 2.
Determining the best acquisition method. As mentioned in Part 1, there are two types of acquisitions, static acquisition and live acquisitions. Typically, a static acquisition is done on a computer system. That means that static acquisitions are always the preferred way to collect digital evidence. However, they have limitations in some situations, such as an encrypted drive that is readable only when the computer is powered on, or a computer that's accessible only over a network. For both types of acquisitions, data can be collected with four methods, including creating a disk-to-image file, creating a disk-to-disk copy, creating a logical disk-to-disk or disk-to-data file, and at last, creating a sparse copy of a folder or file. Determining the best acquisition method depends on the circumstance of the investigation. Creating a disk-to-image file is the most common method and offers the most flexibility for your investigation. With this method, you can make one or many copies of a suspect drive. These copies are bit-for-bit replication of the original drive. In addition, you can use many commercial forensics tools to read the most common types of disk-to-image files you create. These programs read the disk-to-image file as though it were the original disk. Older MS-DOS tools can only read data from a drive. To use MS-DOS tools, you have to duplicate the original drive to perform the analysis. GUI programs save time and these resources because they can read and interpret directly from the disk-to-image file of a copied drive. Sometimes, when you have to acquire older drives, maybe you cannot make a disk-to-image file because of hardware or software error or incompatibilities. For these drives, you might have to create a disk-to-disk copy of the suspected drive. Several imaging tools can copy data exactly from an older disk to a newer disk. These programs can adjust the target disk's geometry, like cylinder, head, and track configuration, so that the copied data matches the original suspect drive. The imaging tools include NCase and X-phase forensics. You can study the vendor's manuals for instruction on using these tools for disk-to-disk copying.
Collecting evidence from a large drive can take several hours. If your time is limited, consider using a logical acquisition or a sparse acquisition data copy method. A logical acquisition captures only a specific files of interest to the case or a specific types of files. A sparse acquisition is similar but also collects fragments of unallocated or deleted data. Use this method only when you don't need to examine the entire drive. An example of a logical acquisition is an email investigation. In email investigation, you may require the collecting only outlook.pst or .ost files. Another example is collecting only specific records from a large RAID server. If you have to recover data from a RAID or a storage area network or SAN server with several exabytes or more of data storage, the logical method might be the only way you can acquire the evidence. In e-discovery, for the purpose of litigation, a logical acquisition is becoming the preferred method with large data storage systems. So, to determine which acquisition method to use for an investigation, consider the size of the source, suspect source, suspect disk, whether you can retain the source disk as evidence or must return it to the owner, and how much time you have to perform the acquisition, and where the evidence is located. If the source disk is very large, for example 4 terabytes or more, make sure you have a target disk that have the proper storage. If you don't have a target disk of proper size, review alternatives for reducing the size of data to create a verifiable copy of the suspect drive. Popular archiving tools such as pkzip, WinZip, and WinRAR use an algorithm referred to as lossless compression. Compression algorithms for graphics files use what's called lossy compression, which can change data. For example, lossy compression is used with JPEG files to reduce file size and doesn't affect image quality when the file is restored and viewed. Because lossy compression alters the original data, it cannot be used for a forensic acquisition. Most imaging tools have an option to use lossless compression to save disk space, which means the target drive doesn't have to be as large as the suspect drive. For example, if you are examining a 3 terabyte SATA drive, you might be able to use lossless compression to create the disk-to-image file on a 2 terabyte target drive. Image files can be reduced by as much as 50% of the original. If the suspect drive already contains several zip files, however, the imaging tools cannot compress them any further. This is because the files have already been compressed, so any additional compression results in very little size reduction. For additional information on lossless compression, you can go to the website that is shown in the monitor. An easy way to test lossless compression is to perform an MD5 or SHA-1 hash on a file before and after compression. If the compression is done correctly, both versions have the same hash value. If the hashes don't match, that means something corrupted the compressed file, such as hardware or software error. As an added precaution, perform two separate hashes with different algorithms, such as MD5 and SHA-1. This step is not mandatory, however, is a good way to establish that nothing has changed during data processing. If you cannot retain the original evidence, drive and must return it to the owner, as in a discovery demand for a civil litigation case, check with the requester, a lawyer, or supervisor, for example, and ask whether a logical acquisition is acceptable. If not, you have to refer the matter back to the requester. When performing an acquisition under this condition, make sure you have a good copy because most discovery demands give you only one chance to capture data. In addition, make sure you have a reliable forensic tool that you know how to use. Thank you so much. It is the end of part 2.